Hey everyone, this is Derek, and this is going to be the second of the 3-2 videos, and this is about inflection points. So the definition of an inflection point is a point on the graph of a function where the concavity of the function changes from concave up to down, or for concave down to up. Or a little friendlier definition, an inflection point is a point on the graph where the second derivative changes signs, essentially, which means we have a concavity change. So if you look at this graph, this is just sort of the picture version of an inflection point. This side seems like it would hold water, so this side would be concave up. This side, somewhere in here, if I chop it, this side the water would run off like a roof, so that side would be concave down. And then the inflection point is the spot where we think that is happening. And what we would do generally, we would be given a function. If we'll see in the next ones, we are given a function, we'll find the point exactly. For this problem and the ones like it, you're basically eyeballing it, and there'll be a pretty obvious spot where you're like, I bet that's the answer right there. So this is going to be at -1, -4. Certainly does not look like a 1. Pretend it looks more like a 1. So that is where the inflection point would be. And so then everywhere from here over, that is going to be concave down. So that's -1 to infinity. And then everywhere from here over, that is like where it'd be holding water. And so that would be our concave up, or our negative infinity up through -1. Okay, so for this next one, we're just to find the inflection points of the function. And so for that, we need to figure out basically where the second derivative is 0. So take the derivative a couple times. We'll go f prime of x equals 4 times a half, or half of 4 would be 2, x to the third. 3 times 4 right there will be a 12, and then x to the second. We get that little invisible 1 times 4, so that's plus 4. And then we'll go one more round and get the second derivative. So 2 times 3 is going to give us a 6x squared. 2 times 12 for 24x. And then the constant term drops out. And now we'll just set this to 0. And there's a GCF of 6x in there, so let's get that factored out. So taking 6x out of there, we'll leave an x. 6 out of 24 leaves 4, and I got the x already. And so that means my inflection points are going to occur at 6x equals 0, so that means x equals 0. And then x plus 4 equals 0, so when we bring that over, then x equals -4. Okay, so this one goes, the company uses the model that to relate its revenue R in thousands of dollars to the amount of money X in thousands of dollars it spends on advertising. Find the point of diminishing returns of the model. So diminishing returns, what that is our inflection point that we're just looking at. So if you think of kind of a curve that's going up, so this is like the idea of the COVID curve also, that's eventually going to flatten out somewhere right around there. So we're going from concave up, right, to concave down. So here the rate of change was increasing, and now the rate of change, is decreasing. And so that little point right there would be the place where if this was our money and like what we're making. So here we'd be making a little bit more, a little bit more, a little bit more. And now every time we make another unit, we're making a little less, a little less, a little less, because you can see that rate of change is flattening out. So that's the same idea as COVID virus right now. It's increasing, but here it's increasing at an increasing rate, and then eventually it starts to increase at a decreasing rate, which eventually will hopefully again lead us to 0. So to do this, we're going to basically just find that inflection point again. So we just need to do some derivatives. Big thing on this is to not do it like that. So first we're going to rewrite this way. And then we do a little canceling right there. And so let me write that a little bit cleaner. Okay, so if I write it this way, this way it feels like a quotient rule, which is not that great. This way it's super easy now, it's just a polynomial. So we'll do here 2 times that 9 will be 18. Oops, I think I actually dropped a 0 there. Sorry, I was thinking something wasn't quite right. So to do our prime, 2 times 9 will be 18 over 200, and then x take away 1 would be x to the first. Here we'll go 3 times that 1, so minus 3 over 20,000, x to the second. And then we'll go one more round, and we'll get our double prime. So there we'd have 1 times 18 over 200, and I'm going to write that as 9 over 100 just to simplify my fraction a little bit. And then 1 minus 1 will give us x to the 0 or 1 right there. And then here we'll have 2 times 3 would be a 6 over 20,000 x. And so then remember, we're trying to figure out where this equals 0, so let me pop over here with it. And so I'm going to go 9 100ths, and then I'm going to reduce right here. Just, I don't have to, but I can knock out a 2, so I'm going to. So I'll make that 3 over 10,000 x equals 0. I'll bring that on over. And then I'm trying to get x by itself. So what I'll do is I'll just multiply both sides by the reciprocal of this fraction. So 10,000 over 3, 10,000 over 3. So that will cancel a couple of those. That will make a 3 times 100. And everything cancels there. So it looks like x is, so it looks like the money spent on advertising will be 300, and that was in $1,000.